Week 2, thank you for joining us. Defining and exploring cohorts. This is going to be a little less content than last time. I'm hoping we're going to have some time at the end to discuss some of your project ideas and to go through that a little bit. I'll have a kind of interactive component towards the end for those who have time. Just to give you a sense, we have completed week 1, navigating TriNetX and developing a project. So we talked about the big picture parts of TriNetX and how to develop projects within it. Big picture objectives for us as well, navigating TriNetX interface, identifying worthwhile projects. This week, we're going to start on objective 3, which is compare outcomes between patient cohorts. We're talking about how to develop patient cohorts in an advanced way. And today's objectives are to use the advanced cohort definition feature to more clearly target your group of interest, to consider and adjust for temporal issues in your study, to examine your cohorts for additional confounding factors and inclusion-exclusion criteria that might not have been included in your initial design, and to develop your cohort construction diagram. I'm going to have a couple of examples, or certainly an example from the project that we're building out as a sample here to help give you a sense of what those could look like. Okay, so just to review our process and refresh everybody from last time, we have completed week 1 in the foundation, in my clunky metaphor of foundations and houses. Week 2, we're going to be looking at term groups and exploring cohort before we move on next week to building the house of our study, which is choosing an analytic tool, cohort comparisons, index events, baselines and balancing cohorts, propensity matching, so forth. And then really exciting stuff in week 4, where we start to look at our outcomes and try to understand the stats that are put out by TriNetX. So, this is a bit of a slow burn, but I think establishing a really strong foundation helps make it a lot easier to do good quality studies later on. Again, in our big picture rapid development process, we're still in box 3, building your cohorts. And next week, we're going to move on to using those cohorts once you can build them. And in our even more rapid process, we're going to teach you the basic tools to do this, to do 4, 5, and 6 in our process here. Again, finally, here's our clunky foundation and house metaphor. But this week, we're really focused on that foundation, inclusion and exclusion criteria, time, order, and frequency of events, and cohort explanation for confounders. And that'll set us up for next week. Okay, example study, just going back to where we left off last week, as we review a couple of things. Our kind of worked example that I'm going to be showing you components from as we go is based on this piece of internet clownery. This gentleman has generally a pretty okay channel on Instagram, but he decided one day to get up on his soapbox to his 1 million followers and declare that Alzheimer's is a physician-created disease and it didn't even exist 40 years ago, not even under another name. All of which is just factually incorrect and inaccurate. A basic Google search will debunk all of these claims. But it did get me thinking about some of these, as I talked about last time, hypotheses. To what degree do statins impact people's odds of developing Alzheimer's disease? There's a number of studies that show that it can have a protective impact, but we don't know the degree to which that's the case. So we've developed some hypotheses to try to understand and quantify this difference. My H sub 0 is that statin use is not associated with any changes in likelihood of development of Alzheimer's disease. There's evidence to indicate that on its face is falsifiable, but let's find out what's going on. Associated, my counter-hypothesis, my non-null hypothesis is this statin use is associated with a lower likelihood of developing Alzheimer's disease. The time on treatment impacts likelihood of developing AD, and dosage impacts likelihood of developing AD. And we're going to develop some of those questions as we go. So now that we have our questions, we can start defining our cohorts. Accurately defined cohorts are essential to getting a reliable picture of the right people. The validity and generalizability of your study comes from how well you can define your cohorts. So one of the core ways that we are going to talk about developing that reliability is through the usage of term groups. Now, term groups help us to identify additional relationships within our cohorts by grouping information together in useful ways. And those groups allow you to connect terms by the number of instances of a specific event. For example, how many surgeries or how many concussions a person has had, the number of unique instances of the terms in the group. Are there 3 of 4 risk factors, for example? Number of related groups, more on this one in a moment, because there's a lot to say about related groups and how powerful that feature is. and also within a specific time constraint. And we're going to talk about that a little bit more as well with some additional details. So to show you here, selecting the create a new group button in a cohort creates that new group. And you can actually create multiple groups within your project to help develop that. So what we want to see here are all people on statins or who have comorbidities. So what we have, what we can do, and have no comorbidities. What we've done here is basically added our comorbidities to the study using the cannot have function. And you can see them all stacked up here. I'm going to talk about this in a minute, why and how I figured to use these particular ones for my Alzheimer's and statins project. And you can see them all stacked up here. That means that at the top level, nobody in my cohort is going to have any of these things at all. So that is helpful because any subgroup I create, these things will be true of them as well. Now you can here see this is the create a group button. You can see it creates these blank groups, and you can add terms from that you've already added in here into these groups. This function allows you to add some additional functionality in there as well. So you can see here, I've created this group where we have people who had, I just need some sort of event to create the starting point for the study. So that's anytime somebody had an aspirin in the health system, that they were ever prescribed ibuprofen or an aspirin or given that during any kind of interaction in their health record. You could pick other things. I just thought those were kind of unrelated enough to the possibility of developing dementia that they would be a suitable starting point as kind of a placebo, if you think of it that way. And you can see here are all my statins. And we're going to talk about how this is set up in just a second. But essentially, once you create that new group, you can also use, some of the functions to, as I said, put anything that's up top here so that it applies to all groups you might create, all groups of terms that you might create will all include this. But one thing that's neat about these cohorts is you can also use Boolean logic to include different combinations of groups. So you can do things like, for example, everybody who had an ibuprofen, aspirin, or one of the statins, and you could create an additional group, all the people with statins at any time, for example, could be added to this group. And that'll allow you to include both of these in your total patient count later. That is a little confusing to say, but I think as we see the implications of this in a minute, we'll learn a little bit about that. So you can use Boolean logic to combine two or more groups. Within the groups, you can set up, as I said, some of these additional tools. You have the number of instances. So as I said a moment ago, this could be where you include all patients must have, at least in this case, 2 instances of ibuprofen and aspirin. Not really sure why you'd need to do that, but you can. This would be useful as I was working with a group not too long ago, who was doing a project on concussions. And with concussions, usually by the third concussion, or the third concussion is considered kind of a cutoff for, or an entry point for chronic brain damage, or for the possibility of brain damage. So that's something where having 3 concussions in here would be really valuable. You could use this function to do that. I'm actually going to remove this right now because I don't need it. But you can also include the number of unique instances of the terms. As I said earlier, this is really useful if you wanted to know 3 of 5 items. Maybe I want to see if people have taken 2 or 3 or more of these statins in the course of their treatment. That would be usable for that. Time constraints, as I said, we're going to talk a little bit about this, allow you to do 2 functions. One is to create an analysis, create cohorts that extend into the past in some time relevant to today. So you can see on the right-hand side over here that in this version of it, using relative time, today is the most recent event that could occur, but you can go back as far into the past as you would like to collect up these individuals or these the cases that get included. So anybody who is more than, say, 5 years in the past, in this case, wouldn't be included in our cohort. And this could be really useful if you're looking at changes in standards of care. So let's say 5 years ago, more than 5 years ago, there was a different standard of care in your field, and you were interested in seeing how that transition impacted outcomes. Well, you could do it this way. And you could also specify sometime, like, for example, between 5 years in the past and 10 years in the past. And that would be an alternative group that you could use as a control cohort to see how past standards of care impacted people's outcomes. Alternatively, if you click this button, and I'll show you where it is in a minute, you can also choose specific dates. I know a lot of people ask questions about COVID or want to know specific outcomes related to COVID. This is one of the ways that you could do that. You could specify between, let's say, March 13th, 2020, and then March, let's say August 15th, 2022. That could be whatever you define as your COVID period prior to the wide acceptance of vaccines. That could be one way you would define that. That'll allow you to specify those dates. And again, a couple years ago, a group of students did an interesting project on crib safety, changes in crib safety requirements. So if you wanted to see injuries or broken bones in infants, you could probably use something like this to see if, since that 2013 law that changed crib safety practices, have we seen a reduction or decline in pediatric injuries related to crib injuries. So you can see, cancel this, under the group rules, you use the add time constraint function to do that. And this is how you'd switch back and forth between specific dates and relative time. Okay, so those are three of the really powerful ones. This is probably the most powerful function in the cohort development section. This is the related groups function. So what happens with the related groups is when you go and start it, it basically allows you to set up, number one, your first cohort of people. I'm just going to add in a couple of things here just to show you. You can create, I'm going to say, we're going to include people who must have heart failure but don't have strokes. But basically, you can create a group B that refers to your group A in time. So one way to think about that is that the relationship, you can choose the relationship whether group A happens chronologically in relationship to group B, either the first instance of group A, so the first time somebody has a stroke, the most recent instance, let's say maybe their third or fourth stroke, or also their first instance or any instance of a stroke could be your choice. So there are a lot of occasions where that's actually really important, the order effect of those outcomes. It could be a second, let's say a second malignant neoplasm that somebody has. You want to know whether it's the most recent one, any instance where they got a particular drug, or the first time that cancer shows up on their scan. And similarly, you can set this so that they're related, so that any instance of your second cohort, let's say a cancer drug, is related to the first instance of that. I'm not sure why you would set that up that way, but there's a lot of options. This actually gives you a lot of really careful control over it, and you really have to use your noggin to really clarify what exactly you're trying to achieve with your question that way. Because the upside to this is you can set, really precise relationships between your groups and your let's say, treatment areas. In this case, we want to say that the first instance of heart failure occurs within the most recent instance, let's say, of a statin or something like that. So we could add those terms in to this group, and that'll we only want to see, you can see here it actually creates the little text from that. The most recent instance of our, let's say, statin occurred within 6 months on or before the first instance of heart failure. So those are the kinds of really complex relationships that you can set up that may be a little abstract. So let me see if I can come up with this example over here. basically what I set up was two things. One is my group over here that has the ibuprofen and the aspirin, because there has to be something in here that defines this cohort positively. And here are all the things they can't have. And similarly, the first instance of my statin group occurred within 5 years before or anytime after any instance of group A. And so I set it up that way so that if you really think about it, they could have been on a statin for as long as 5 years, or it was prescribed the day before people enter our study. And you can also control it much more carefully. I think later on, I also used versions of this that people had to have been on statins for between 1 and 5 years in order to become part of our cohort for that to work. So 1B includes our statins and that temporal relationship in relationship to A, and 1A contains all of our negative criteria and also 2 positive criteria. The way I really recommend it is kind of how I just did this, to check your logic and make sure you fully understand your settings. Really try to say it out loud. So this group includes everyone who ever had an aspirin or ibuprofen, but did not have any of our comorbidities, and their first instance of the statin within 5 years before the aspirin or ibuprofen. So if you say it out loud like that and really think it through carefully, you'll be able to get a lot of temporal control over the relationship of these drugs. And that's important for illustrating cause and effect, because we can't go in there and read the doctor's notes about exactly why these things were prescribed. So we have to rely on temporal relationships that help to indicate what's going on. What's cool about this is you can also use what they call on the TriNetX folks call a stepwise approach to creating related groups. So let's say that you have several different combinations of things you want to include. You can only create one related group at a time. So you can only have 2A and 2B. You can only have 1A and 1B at a time, but you can use multiple ones, like 1A, you can see here we have it set up. So 1A and 1B are related. You could make a clone of that exact thing and change some of the parameters to reflect an additional group you want to capture in your cohort. And you can use the OR function to that. So what you would see is all of group 1 gets included in your patient count, and all of group 2 would also get included in your patient count. Similarly, though, if you wanted to include people, you could switch this and have and say, and I want to see people who had a emergency room visit within 6 months of being prescribed their statin for some reason. You could set that up, and that would then create a more precise patient count for you later on. So you can use this, what they would call a stepwise approach, to chain together multiple groups to get exactly the subset of people you want, who are defined in just such a precise way. So group 1A and 1B, and group 2A and 2B, where 2A is like a copy of 1B. And just to show you, you can create copies of these groups really quickly. You can hit copy like that, and then you go down here and you hit paste logic, and it will paste in your entire group. So group 3 is now an exact copy of group 1, and I'm going to hit like this, and I'm going to say I want to see everybody who was on was on a statin for longer than 1 year, but I want to say it's any most instances. So I don't really have a logic for why I would do this, but just to give you a sense of how you can relate these things chronologically like that. Yeah, as I said, copy paste logic, and you can use either and or to catch either group 1 or 2, or and group 1 and 2. I know that's a little confusing. There's a lot going on with that. So I just want to do a quick check-in. If you have any questions, please put them in the chat, and I'll be happy to take you through it a little more and to help explain a little bit about what some additional features could be used for. Okay, so while you're all typing in the chat, just out of abundance of care for our time tonight, I want to take you through another function that's really, really important for making the best use of TriNetX. So I'm going to try, I think I have this one already set up. But this is a function you see over here on this window called the explore cohort function. Now, what this does is before you even proceed to start analyzing your cohort and finding out what's going on with them, you want to look inside and see who's included, right? Who's, whether there are any things you're missing in terms of comorbidities, any types of complicating factors that might get in your way. Are there any demographic factors you might want to consider? Like right out of the gate, I can see that my no statin by no Alzheimer's disease comorbidities group is almost 18% more higher in, it has an 18% higher chance of being female in this group. So there's 18% more women in this cohort than men. That's something you probably want to consider and look at in the future. So you can look at, as we discussed before in the cohort, doctors don't pay money late. So make sure to check your demographics, your diagnoses, your procedures, your medications, and your labs. And I'm just going to quickly kind of take you through some of those. As I mentioned with the with your demographics, you can see it kind of laid out this way. In this case, I cut my study at 45 years because we anticipated that that's kind of the peak of people starting to get their hyperlipidemia treated using statins, or having that used as a preventative measure in some other condition. So this is our demographic functions, pretty similar to the way the other part of our information is set up on the query builder side. I have a question, sorry, as I move on to the diagnoses, I have a question from someone in the chat. Is family medical history possible to capture? To the degree that that's something that's actually captured by the Z codes in the health record, yes. So a lot of people, when they have a family history of something or another, it actually gets thrown in. I might as well show you on this one. It gets thrown into this bucket of the Z codes. So let me just see if I can find it here. It's in one of these categories. There's an option that says family history. Oh, here we go. Persons with potential health hazards related to family and personal history. So if they ever say to their doctor that they either personally or have a family history of, for example, cancer, here's your family history of primary malignant neoplasm, family history of certain disabilities and chronic diseases or things that lead to disease, personal history of medical treatment, all those things are listed in there. So if you have a project where you want to include or exclude people who have a personal history of a disease, that's entirely possible to do. Here, I'm just going to open this one. Just to take you through this, this is a screen we're going to see next week in the context of the analysis. But in the diagnoses function, you can see it'll lay out for you the entire list of all of the ICD-10 codes, as well as all of the percentages of the cohort that have a code in that area. So you can see that in our Z code, 62% of people have something from a Z code in their record, in addition to all of the things we're looking at. Now, you can do some additional really important and cool stuff with this using this function over here. You can look at this within 3 months of the entry of the person into our cohort, 6 months, 12 months, or 24 months. So we wanted to say 24 months after the people started in our no statin, no AD comorbidities, what's going on with them. Similarly, you can include acute or chronic diseases as well in there, and you can filter this by acute or chronic diseases depending on what you're working on. So you can see here actually our metabolic disorders. We've already excluded a whole range of metabolic disorders in here, but none of the ones that we had, because I'm filtering against them. None of our actual interest ones are in there. But if we wanted to exclude people with a family history, one of the most useful things about this is if you see persons okay, let's say persons with potential health hazards. So someone who's been exposed to a communicable disease. Let's say you want to exclude that from your study because you're worried that it's going to confound your results. Well, you can click on it here in TriNetX, and you can click on any of the layer of it and add it to your must have or cannot have function automatically. So if you click this button, it'll automatically show up back over here in your query builder, all the way usually at the bottom. So contact with suspected and exposure to other communicable diseases. That one I just included shows up right there. So those are some of the key features in the diagnoses function. Yeah, you could select that. I do not recommend, when you're doing this kind of thing, adding the top level codes, like where it says E00 to E89. There's just too much variability in terms of what's included there. So I really recommend digging down a couple of layers. You don't have to pick each individual one. You could pick, in this case, we're looking at hypertensive chronic kidney disease. You could pick the I12. You don't have to pick the I12.0 unless end-stage kidney disease is the only thing you're looking for. If you're looking for any kind of kidney disease, you can just pick I12 and include it or exclude it in your study. But this is a really, really, really useful time saver of a feature. One thing I do want to call your attention to is this function up here. This is an export function that allows you to export this chart as an image or as a CSV file. I won't do it right now just because it takes a minute to output, but it'll actually dump everything, your patient numbers and each ICD-10 code all the way down, and the percentage of the cohort to Excel, which makes it so much easier for you if you want to, let's say, develop a table where you want to look at how much one cohort versus the other cohort has risks of snoring. You could easily dump both of your cohorts to Excel and copy paste it from there instead of having to go search through the interface, the web interface, even though you can actually search for snoring directly here. You can see here's our 2% of people who have that. So yeah, this is a new feature. Being able to just dump this whole thing to Excel has been really valuable. And another thing about it that's really useful is you can then take advantage of some of Excel's functions. So you can use Excel to sort the data in order to you can have it rank it, for example, from let's say in this case 83% of people having that code. You can have a reverse sort where it'll go count down to 0, and then you can ignore the ones where 0% of your cohort or a functionally 0 equivalent percent of your cohort is impacted, and focus on ones where 20, 50, 70% of people are impacted. So Excel's tools coupled with this function in TriNetX can be extremely valuable. Procedures, in addition to, pretty much works exactly the same way, but procedures use the CPT codes, billing codes that are structured around specific procedures. Now, one thing you should be aware of is that CPT codes are maintained by the AMA. It's one of the ways they make their money, and they're very expensive. So some systems have opted instead to use ICD-10 PCS codes or HCPCS PCS codes. And these are more used globally because they're free and open source, and you don't have to pay the AMA to get the most updated ones all the time. But they are something you need to be aware of, because depending on which one the system, it's kind of like measuring in feet and centimeters, right? You need to be aware of both, or weight in kilograms and also pounds, because you might find some systems are using the AMA function, the AMA, and some systems are using ICD-10. And if you're not using both, you may miss out on some things. So I just like to make people aware of that. Similarly, medications, they're grouped by type and use, which is super handy because if you are looking for your statins, they're all going to be in one bucket, which is really helpful. So you can look for your statins this way. Is it under blood products? No, this is Oh, here we go. Okay, no, that's not the right one. Let's get to our bucket of them. Oh, well, in any case, it is possible to use them to identify your buckets of statins, as well as your antivirals and your antifungals, anything you might be looking for in there, and your dermatological agents and things like that. So those are things that's a really handy tool for identifying any additional drugs you may want to keep or cannot have in your study. Labs are really useful as well because you may, in it, for just 1 second while I get back to screen. Labs are really useful because in addition to the functionality that's available within the query builder, you can use the labs tab to find both common labs and uncommon labs. We were just using this to look for very specific tests for specific kinds of bacteria and viruses that might be we might want to see whether somebody came up positive or negative, or even just how many of these tests were ordered. And so you can access the kind of basic level of labs, like most of the stuff you're going to be mostly interested in most of the time. You can see the metabolic panels. These are all TriNetX curated ones, meaning they brought together a number of different codes to allow you to be able to find these really quickly. So liver tests of liver function, coagulation, your lipid panels, endocrinology, all that kind of stuff, tumor markers for those where they've been collected. So these are your kind of common labs. And as I said, you can switch to your all categorical labs in order to see the whole range of everything that's out there. And it'll also tell you what percentage of people have had in your cohort have actually had these data collected for them, and the distributions of those values in there. One thing that's super useful, though, is in your lab profiles. When you click on these, right, here's amphetamines. That's probably not going to be an interesting one, actually. Go back to some of our common labs real quick. So when we're looking at our common labs, you may want to look at I'm going to go with the glucose volume. So when you click on this, it's really nice because it'll, number one, show you your distribution as well as your mean and your standard deviations in here. So this helps you decide where you want to, what values you want to include in here based on all the values that are in your cohort. That can be really, really valuable in helping you get to your accurate cohort faster. Because you might want to say, we're only interested in people over the mean, but by up to 2 standard deviations. And that's going to capture most of the people, most of the use cases in here. And you can then see what that value would be. It looks like the value is about 170. So you could say we're going to go from 104 to 170 on that. We have a question here. How does the system track and merge patient records if the same patient receives treatment at multiple locations, organizations? The answer is that it doesn't. If the person, this is all done by the electronic health record. So if a person goes to get something done, get a lab value, for example, done outside of it, it won't show up unless that lab value is pulled in. So for example, if somebody goes to LabCorp to get their stuff done, and it gets pulled into the electronic health record of the system, then it'll show up there. If it doesn't, if it's a system where they're not collecting that, or it's at an independent practitioner's office or something like that, then no, it wouldn't. Their most recent value wouldn't show up. This is the data is only going to come from the health systems that are joined to TriNetX. Really quickly, I also wanted to share with you a function that looks kind of boring. It's called summary statistics. And it's not super interesting. This just tells you mostly about the length of patient records in terms of months. It tells you about the number of facts, that is, drugs, tests, values, those kinds of things in each patient record. But I think the thing that's in some ways most interesting in this function that I wanted to share was by geography. I get a lot of questions. As I said last time, geography is really not a great, TriNetX is not a great tool for looking at geographic distributions. However, this is kind of the largest level at which we can look at it. So there are a number of things that could be interesting that you would see in terms of outcomes in the South versus in other areas. So if you wanted to know, are there more patients on this front in the West than in the South, you can see it'll show you this heat map of those regions. So that's about as good as we can do on geography, but there may be a study where you would be interested in differences across regions. Yeah, that's the best we can do in geography, but kind of cool and pretty useful. And you can look at it cohort by cohort. So if you wanted to look at differences in distributions by region, you definitely could do that. Okay, so what I want to talk briefly about was building what we'd call a counter cohort. So if you're comparing outcomes for a group, like an experimental and a control group, for example, you can use your experimental group to quickly create your second cohort. So just to give you a little bit of a sense of how I did this for some things, what I did to create my no statin group was first to create my experimental group here, my statin group, and then I basically just deleted this group, and that allowed me to, when I deleted it, it added these cohorts up here, and then that automatically created my no statin group over here. So what I guess I'm suggesting is, by thinking through the order, whether it's easier for you to create your experimental or your control group first, depending on the complexity of that, it may be easier to think through which one you want to create, and then whether you can quickly devolve it into the other cohort. So, for example, you might create a cohort where you're looking at COVID in one and the flu in another. Well, it may be possible to create your for something simple like that, you can create your COVID cohort and really easily just add, switch it and move your COVID term from one side of from your cannot have to your, from your must have to your cannot have. And then you can add, for example, your flu, your influenza over here instead. There we go. So you can, now we've created our counter cohort. We need to flip them. We can just move them around like this. And oh, look, now we have our control cohort or something like that. So what I'm just suggesting with the cohort and counter cohort approach is to, basically think about which one is easier to construct first, and then devolve it into your other cohort. Let me see if I can just come up with an example. What I did was, for this one, as I said, I deleted my group, and that added all of my statins back up to the top, to the must-have. I'll show you really quickly. If you delete, if you delete your group here like this, all of your terms are going to go right back up to the top here, and then you can just move those over. So now here we're going to have people who never had any of our statins as we start just moving these over. So rather than having to completely start from scratch and build a whole new cohort, we can kind of move these over, and then we've got our counter cohort here. And in fact, we can go back and just delete this group as well and ungroup all the terms. And they're otherwise identical, except they're the opposite. So Does that help a little bit? We had a question in the chat about to explain exactly what I'm talking about, but I just feel like, yeah, if you think about which one you can devolve from more easily and start with that one, constructing that one first, it makes it a lot easier to, rather than having to re-enter all of your terms each time when you're doing this. Can we get any information on the patient's diet? I'm going to guess no, unless that's something that's part of their electronic health record in some way. There could be a subset of people, I'm not sure. Maybe some people have been prescribed keto diet or something like that. But otherwise, no, we wouldn't be able to see what is in their diet. There may be some students have gotten clever with using Z codes, and there may be a Z code related to a vegetarian diet or something like that, and that's something we could take a look for. But otherwise, it would have to be something that is structured data. Okay, so like as I was saying, ideally think about which will be easier to build first. Consider which one will be easier to convert into its opposite, or if you're doing a control. The no statin group is much simpler than the yes statin group, so I built the yes statin group first and turned it into the no statin group. All right, so going back to our worked example, just to take you through a little bit about how I kind of tried to do this quickly in refining your cohort. I strongly recommend using AI, or like you can use your preferred one, whether it's ChatGPT or I like Perplexity for a lot of stuff because it's very it's bound to use peer-reviewed data in its responses. So I used Perplexity to ask, what are the principal comorbidities for Alzheimer's disease that I need to consider? And it actually spat out a really good list. Some puppy time right here. But what are the principal comorbidities for Alzheimer's disease? And it spat them out. And that actually made it very easy for us to figure out really quickly. Now, of course, there are tons of resources out there that will summarize this information for you, but using AI judiciously can really help to make that process go faster. So here were the exclusion criteria that, as I reviewed them, seem to have really strong evidence. And you can see, as I added them, I also included the ICD-10 code and the number of cases in each one. Okay, yeah, we can take a look and see if diet is included in the order set. So why did I include these? Well, we've got things like metabolic hypotheses for Alzheimer's disease, neurological hypotheses, cardiovascular hypotheses, and also viral hypotheses related to things like HPV, and also prion diseases as well. So we wanted to make sure that we included pretty much the kitchen sink in getting a real crystal clear view of our cohort. Some things I excluded based on the research. Why not cancer? It turns out that I asked Perplexity this, and it turns out that histories of cancer are associated with an 11% reduction in Alzheimer's disease diagnoses. Cancer patients have slower cognitive decline, and it does not appear to be related to chemo, radiation, cancer drugs, or other treatments on that front. So no one's quite sure what's going on with that, but it was something that I found we didn't usually control for malignant neoplasms as a component of almost any study you would want to do. But in this case, it wasn't a factor. Again, you can use the can't and must have to look for additional diagnoses that you might want to look for. Okay. I just want to conclude my prepared stuff tonight and give us a little bit of time for groups that may want to discuss. With cohort diagrams, this is a tool that's available through the resources function on the Scholarly Activities page site. Basically, the goal here is, whether you're doing this for your poster or for a publication, is to provide a clear, succinct map of relevant inclusion, exclusion, and cohort criteria. And it does not have to look exactly like this. This was just one that I found that was pretty good from an existing study. And I just want to show you, this is kind of what my worked example looks like so far. So using the TriNetX network in July 2024 with 115,945,000 people in it, the number of people over age 45 was 59 million people. I excluded all of these people. And the reason that, this adds up to probably more than 59 million people, but there's like a Venn diagram, if you imagine it, of these people in our cohort. So the total remaining pool meeting exclusion or the inclusion criteria were about 4 million people, of whom we had about 3.1 million in the no statin group and 873,000 in the statin group. And we're going to look at this from 5 years before to any time after when we finally do our analysis next week. Always make sure you double check your math to make sure it's accurate. You don't want some peer reviewer catching that. But I do want to note, though, that because of fluctuations on the TriNetX network, on any given day, your numbers might change a little bit from one day to the next. So the total number of the people on the network, the total number of the people in the cohort, number of people in your analysis, they can increase or decrease depending on whether a new system, whether they've updated their data recently or anything like that. I think just while I was preparing this study, we were, I think, the 64th health system to join. And since then, 2 more systems have joined, bringing it up to 66 in the US. So that added another 1.5 or 2 million people to the overall network, which means your numbers from last month may have changed a little bit to this month. So always use the numbers from the day that you run your last version of your analysis for your write-up. Obviously, by the time it gets into print, those numbers will have changed again, probably, but it will have been true at the time that you did it. And if you did a good job on your study, that should be okay. All right, so that's the main thrust of our discussion today. I did get some really great feedback from a student who asked if we could have a little more time to discuss our projects and discuss our projects together. So I tried to come up with a really simple team formation discussion thing. I think we have about 24, 25 people here today. I was thinking about opening up 11 breakout rooms. And if you want to get in there, we can hopefully see if there are people with common interests that you might want to work with as you're developing your project. And hopefully that'll be a useful way to help people identify potential collaborators. So I'm actually going to pause. Oops, I'm going to pause the recording. Stop recording. And if anybody wants to say anything, please just go right ahead and